All right, welcome to the second day of the 7.3 Graphing Rational Functions notes. We're going to start with letter C since we skipped that one on the first day. But where all of these start is you should always look for factoring. In this case, 6 definitely already factored as much as possible. X squared plus 1 also already factored as much as possible. This is not a difference of squares because it's not a minus sign. It's a plus sign, so we keep it just as it is. Your next step after looking at if anything factors should be checking for vertical asymptotes or types of discontinuity. So to do that, we set the bottom equal to 0. So we set x squared plus 1 equal to 0. And we try to solve for x here. So we're going to subtract 1, and we get x squared equals negative 1. Well, if we solve this for x, we would get not real solutions. They would be imaginary. So in this case, because we would get imaginary values, if we tried to set the bottom equal to 0, it actually doesn't have any vertical asymptotes because there is no real number that would create any type of infinite discontinuity here. So there's no vertical asymptotes, there's no discontinuity, and if neither of those things exist, that means the domain is just all real numbers. Next, we're going to go to the horizontal asymptote slash end behavior. So horizontal asymptote slash end behavior. And in order to do these questions, you set the biggest x on the top, and you divide it by the biggest x in the bottom. Well, the biggest x on top is this one, right? X to the 0 power, technically. So we can just say 6 divided by the biggest x in the bottom, which would be x squared. Which, when you look at this tells us that because the degree on the bottom is greater than the degree on the top, our horizontal asymptote slash end behavior is just going to be y equals 0. And if you forget that, you can come back to your notes at the top here and you can look, right? It says, if the degree of the denominator is bigger than the degree of the numerator, you should get y equals 0. And that's what happened here. So we come back down to C. Y equals 0. We can draw that one in. Perfect. Now we're going y-intercept. Remember, to find the y-intercept, you just plug in 0 for x. So this is going to be 6 divided by 0 squared plus 1, which gives us 6 over 1, which is just 6. So at 0, we got out the value of 6. And then x-intercepts here. Remember, x-intercepts come from setting the top equal to 0. In this case, when you try to set 6 equal to 0, hopefully you recognize that 6 does not equal 0. So there is no x-intercepts here, so it's not applicable. Well, what in the world does this graph look like then, Mr. Heinlein? That is a great question. All we have is this 1 point up here at the y-intercept. So the best thing to do is to just start picking points to the left and to the right, try to get an idea of what's happening here. So if I want to go to the left, I would say let's plug in negative 1. So we go 6 divided by negative 1 squared plus 1. That would give us 6 over 1 plus 1, which is 6 over 2, which gives us 3. So when we went negative 1, it came to 3. Okay. Let's plug in positive 1, see what happens. So 6 over 1 squared plus 1 is 6 over 1 plus 1, which is 6 over 2, which gives us 3 again. So we go positive 1 up to 3. Okay, so it looks like it's kind of like a parabola. We could plug in more points if you have a good idea of what's happening here, right, because of these end behaviors. You could graph from these 3 points. But let's just see, right? Let's go one more over. Let's see what happens. So let's go negative 2. So 6 over negative 2 squared plus 1 would give us 6 over 4 plus 1, which gives us 6/5. If you plug in positive 2, it's going to give you out the same answer because you're just plugging in, you're squaring whatever you plug in. So that's 4 plus 1, which is 6 over 5, so 6/5, right? So that's barely over 1. So we plugged in negative 2, we're barely over 1. Plug in positive 2, we're barely over 1. Okay, so that gives us even a better idea. It's looking like this graph is going to hug the horizontal asymptote, come up through these points. At the top here, it's going to curve, and it's going to come back down. And then it's going to go through those 2 points, whoops, and go back to hugging the end behavior / horizontal asymptote. And there's your graph. Again, like I said yesterday, all of these graphs look different. It's very rare to come across ones that look the same. But as long as you follow the process, you should get there, all right? And sometimes the process includes a lot of this 6th step. If necessary, find points near vertical asymptotes by substituting in x values. I guess instead of just vertical asymptotes, this should just be, if necessary, find points near points you know by substituting in x values. So that would be what letter C looks like, kind of like a little bump in the road, right? All right, let's take a look at E. E, again, we're looking for factors here. So we have x minus 3 in the top. In the bottom, I believe this factor is x minus 2, x plus 1. Yeah, that should work. Okay, nothing cancels, so no point discontinuity to worry about here, but we do have 2 vertical asymptotes, right? The vertical asymptotes come from setting the 2 denominator factors equal to 0. So it's going to give us x equals 2, x equals negative 1 for the vertical asymptotes. Let's write those as 2 separate equations. Discontinuity, type, and location, we have infinite. It's the only type that we have, and it's at 2 and negative 1 for x values. Let's say x equals 2 and negative 1. Domain, all real numbers. X cannot be 2 or negative 1. And then we can graph that. So let's go positive 2, negative 1. All right, on to horizontal asymptote / end behavior. So when you look at this one, remember we always compare highest degree in the top to highest degree in the bottom. So that's x over x squared, which when you reduce that leaves you with 1 over x. Whenever there's x's left in the bottom, or you notice that the degree in the denominator is higher or larger than the degree in the numerator, this tells us that the end behavior or horizontal asymptote is just y equals 0. That happened in our last one too. So y equals 0, we have this dashed line. We are allowed to go through these end behavior lines now, okay? They're not like our vertical asymptotes. We cannot cross a vertical asymptote, but we can sometimes cross horizontal asymptotes / end behaviors. And that's why I call them end behaviors more so over horizontal asymptotes. Next, we have our y-intercept. So our y-int, remember we need to set x equal to 0. I'm going to go original equation for this. So that's 0 minus 3 divided by 0 squared minus 0 minus 2. So that's going to leave us with 3 halves. So when we plugged in 0, we got out 3 halves, or 1.5. So at 0, we should be at 1.5, right in the middle. And then let's go to our x-intercept here. X-intercept, make it pink, x-intercept. Remember, that's going to be set the top equal to 0, so 0 equals x minus 3. Add 3 to both sides. 3 is equal to x. So that's going to give us 3, 0 for the x-intercept. Right? Well, how is it possible to have an x-intercept? And like I said, it just means that we're going through the horizontal asymptote / end behavior, which is okay in these graphs. So we need to figure out some stuff. We need to figure out which section of the graph we are here. We need to figure out where it's going in the middle. And we need to figure out what's going on in this section to the right. So, easiest way to go on the left side pick some x value over here, which means we just need to pick an x to the left of -1. And I say we pick -2. It seems pretty easy. So if we go -2, let's make this a different color. That purple's good. So -2 minus 3 divided by -2 squared minus -2 minus 2. So that's -5 in the top. In the bottom, that's 4 plus 2 minus 2. So that's -5 fourths, which is going to be -1 and 1/4. So at -2, we're -1 and 1/4, which would put us right here. And having 1 point near horizontal asymptotes or vertical asymptotes is good enough because we follow the asymptotes and we go through the point. So there's that left side of this graph. Okay, in the middle, definitely probably need to find some points here to see where exactly this graph is going. I would start maybe by plugging in +1. Let's see what happens when we plug in +1 here. We're going to go 1 minus 3 over 1 squared minus 1 minus 2. So that's -2 in the top. 1 minus 1 would cancel, -2 in the bottom. That leaves us with +1. So we plugged in 1. We got out 1. Okay, so it's looking like it might do kind of like a cubic-esque function. Let's make sure that's happening though, because I would always suggest going at least 3 points in the middle here, because it could do a weird parabola shape where it kind of goes down and comes back up. So let's go one more just to be safe. Let's go 1 point. We could go 1.5. We could go to the right of 1, or we could go -1/2. Either one is doable here. But that's going to give us a decimal. So let's just plug this one into our calculator. So if we want 1.5, it'd be 1.5 minus 3 divided by 1.5 squared minus 1.5 minus 2. So it gives us 1.2. So as you can see, we went 1.5, and it actually gave us 1.2, which tells us this is one of the weirder looking graphs that comes back up, even though it goes down. So there's that middle section, which is why it's super important to always graph at least 3 points in the middle sections of those graphs. And then lastly, we just need to figure out what is happening to this graph over here. It might take more than 1 point here for us. Let's think. If we went, let's go this number. So that's 1, 2, 3, 4. So let's go +4 to see what happens to the right of this point. So we're going to go +4, which is going to give us 4 minus 3 over 4 squared minus 4 minus 2. So that is 1 divided by 16 minus 6, which gives us 1/10. So at 4, we're at 1/10, which means we are just barely positive at 4. Okay, so that actually gives us enough information to say what happens on this section. We're actually going to come up from the vertical asymptote, go through the x-axis, and then it's going to curve back down and follow the horizontal asymptote. The reason it's going to do that, and it's not going to do something like this, come from the top and then go back down and then curve, is because we are physically not allowed to cross the x-axis again. We can only cross the x-axis at this one point that we found there's an x-intercept there. And because the next point to the right was positive, it meant that it came up and then it came back down and hugged the horizontal asymptote. All right. If that 1/10 would have been -1/10 or a negative number, then our graph would have came down from the top, went through and hugged the asymptote at the bottom. But instead it went the other way, so our graph looks like the one above. This one is a pretty hard one, all right? We had to plug in a lot of points to find what was going on. If you're ever completely lost on a question like this, hopefully you can find the asymptotes, the vertical asymptotes, and the end behavior. Once you find them, just start going crazy plugging in points in all three of these sections. Plug in 1, plug in 0, plug in -1, plug in, just plug in points in those sections to help you figure out what is happening on this graph. The more points you plug in, the closer you'll be able to get to what this graph actually looks like. All right, so that is letter E. We're going to skip F. F is a great one to try on your own. Would be super helpful for like studying for a test or a quiz. Definitely try F sometime just to get more practice of these types of questions in. All right, let's go to G next. Again, look for anything that factors. In this case, nothing factors here. So we're going to set the denominator equal to 0, find that vertical asymptote. So we're going to go x plus 1 equals 0, which means x equals -1. There's our vertical asymptote. So the discontinuity is infinite at x equals -1. Domain of this function, all real numbers. X cannot be -1. Horizontal asymptote / end behavior. Okay, so we have a new thing coming up that we have not seen yet before. 2x squared divided by x. So we go 2x squared over x. In this case, the numerator degree is bigger than the denominator degree. So what's going to happen here is there is going to be a slant end behavior. So how to do this? Come back up to our notes. It tells us if the degree of the denominator is smaller than the numerator, what do we have to do? Long division or synthetic division. So refresher on how that works. Come back down here. We're going to take the whole equation, so 2x squared, and then x plus 1. On the outside of your synthetic division is the 0 of the factor x plus 1, so -1. On the inside of your synthetic division is all of the coefficients and the constant of the top thing that is getting divided. In this case, it's literally just 2. So we're going to drop down 2. And then physically, we wouldn't take this anywhere. I guess we need 2. There's a constant term. Technically, it's 0. Oh, yeah. Sorry. 0 because this is x, and then there's a constant that's also 0. So we need all of those things, right? So we drop the 2, multiply by -1 to get -2, and then you add down, so -2. And then you're going to multiply again, gives a +2, add them down, gives you +2. Remainder, constant, and x. There's our 3 terms that make up the end behavior equation. So we have y equals 2x minus 2 for our end behavior. And now we can graph all of that stuff. So at x equals -1, we have a vertical asymptote. The end behavior is y equals 2x minus 2. So minus 2 is the y-intercept. Slope is up 2, right 1, down 2, left 1. Going to need a dashed line right here for that end behavior. So it's going to look like this. And this. There's our end behavior of this graph. And now we can find the y-intercepts. Y-intercepts come when we plug in 0 for x. So that's 2, 0 squared, divided by 0 plus 1, which is 0 over 1, which is 0. So 0, 0. On the other side, or the x-intercept, for the x-intercept, you always set the top equal to 0, so 0 equals 2x squared. divide by 2. So 0 equals x squared square root. 0 equals x, which makes sense, right? The x-intercept should be at the origin as well, because the origin is also an x-intercept. And that's actually enough. We have enough information to graph this thing now. I know we didn't do a lot, but that end behavior tells us a whole bunch. So to graph this thing, we follow the vertical asymptote, go through the point that it gives us, and then follow the end behavior away. On the other side, we can never cross the x-axis again because we've found all of the x-intercepts, so nothing goes here. On this side, if you would graph anything here, we would fail the vertical line test, which would mean this would not be a function. So we also cannot graph anything here, which the only section left to graph in is right down here, right? So then this graph is going to come just like this. And if you don't believe me, plug in -2, right? Let's plug -2 in to our equation. So 2 times -2 squared divided by -2 plus 1. That's going to give us 4, so 8 divided by -1, which gives us -8. So at -2, we should be at -8. 1, 2, 3, 4, 5, 6, 7, 8. So it's right here. So technically I was off just a little bit on my graph here. Can adjust that. Just pull it down just a touch. And there we go. That's the graph. So slant asymptotes or slant end behaviors, a little bit weird, right? These graphs definitely look the weirdest that we've ever seen. But that is that question. All right. We're going to skip H. H is very similar to F. We'll come back to H, though, and try that one out. It's just one of the harder ones, or the hardest ones. So we're going to wait on that one for a second. Let's take a look at I first here. So I is actually already factored for us. X minus 2 is squared. Right, so we set the bottom equal to 0. When you set the bottom equal to 0, you solve for x. So x minus 2 equals 0 when you square root both sides. So x equals 2. That gives us the vertical asymptote. Discontinuity is infinite. At x equals 2, domain all real numbers, x cannot be 2. Perfect. Horizontal asymptote slash end behavior. We have 4 over an x squared because this x would get squared eventually. So it's 4 over x squared, which this tells us that y is equal to 0 for our end behavior here. So y equals 0. So let's graph all those things. X equals 2 puts us here. Y equals 0 puts us right there. Now we need to find y-intercept. So y-intercept, we plug in 0 for x. So this is 4 divided by 0 minus 2 squared, which gives us 4 over -2 squared, which gives us 4 over 4, which is just 1. So when you plugged in 0, we got out 1. We can graph that point, 0, 1. X-intercept, we set the top equal to 0. So 0 equals 4, which doesn't happen. So there is no x-intercept here. And we can actually graph the left side of this equation right here. Comes through that point, hugs the horizontal asymptote and the vertical asymptote. Okay. Now it just depends, well, are we in the top or are we in the bottom on the right side? So we're going to have to plug in a point here to figure that out. So let's plug in, we need to go to the right of the vertical asymptote. So 1, 2, let's plug in 3. Let's see where 3 ends up. So if we go 4 over 3 minus 2 squared, because we're plugging in 3, so it's 4 over 1 squared, so that would give us 4. So when we're at 3, we're at 1, 2, 3, 4, which puts us right here. which tells us we are in the top section of this graph, which we can graph that. And there's letter I, kind of like a volcano, sort of. It's going like lava spewing out of the top, you know? I don't know. That was kind of dumb. Anyway, that's letter I. Let's do one more. Let's take a look at H, because these are the harder ones. So we should look at it. First things first, factor what can factor. In the top here, we could definitely pull an x out of everything because there's x in all of those terms. So that's going to be x, which leaves us with x squared minus 2x minus 8, which I think that does factor again. Let's see. Let's factor the bottom, though, while we're at it. So that's going to be x plus 2, x minus 1 would give us the bottom. Okay, if we keep going on the top, x, this is x minus 4, x plus 2. In the bottom, x plus 2, x minus 1. So we have a point discontinuity show up because those x plus 2's cancel. So our final equation that we're really going to focus on is x times x minus 4 divided by x minus 1. So let's start with that point discontinuity that we just saw. So point disc, the x value, we can say there's point disc at an x value of -2. So we need to plug -2 into that new equation that we have. So we're going to go -2 multiplied by -2 minus 4 divided by -2 minus 1. So that's -2 times -6 over -3. So what is that going to be? That's 12 over -3, which gives us -4. So we can describe some point discontinuity at -2, -4. Next, we can do the vertical asymptote as well. Because we have x minus 1 in the denominator, we set that to 0, so add 1. X equals 1 for the vertical asymptote, which tells us infinite discontinuity at x equals 1. And then that tells us the domain. So all real numbers, x cannot be -2 or 1. Let's draw all that stuff in. Just found a lot of information. So -2, -4, there's a hole. At +1, for the x value, we have vertical asymptote. Perfect. On to the horizontal asymptote / end behavior. So we just compare the two highest degrees, x cubed over x squared. So x cubed over x squared. Numerator degree bigger than the denominator degree. That means we're going to have to use synthetic division. So the only x in the, I guess we need to look at, we need to look at the new equation. I forgot. We're done with the beginning equation. We're looking at the new equation. New equation, though, is still an x squared. Let's FOIL that out. It would be x squared minus 4x over x minus 1. And so when we do synthetic division here, we would go 1 on the outside, and then the coefficients on the inside, so 1, -4, 0 for a constant, because it's x squared, x, and constant term. To do synthetic division, we drop the 1. 1 times 1 gives us 1. And then we add down, -4 plus 1 is -3. -3, we add again. So remainder, constant x. So our horizontal asymptote / end behavior is y equals x minus 3. We don't care about the remainders in these equations. So -3, so 1, 2, 3 puts us here. And then the slope is +1. Yeah, slope is +1, so up 1 to the right 1. And then we can draw in a graph. Should look just like that. Draw in a graph the other direction. Right there. And that actually gives us enough information to draw this left side. I guess we can be a little bit more precise. Definitely going to go through the x-axis and the y-axis somewhere. So let's find those points. So y-intercepts, remember we plug in 0 for x. So this is going to be 0 squared minus 4 times 0 over 0 minus 1. So that's 0 divided by negative 1, which is just 0. So y-intercept at 0, 0. Nice. We do go through that point, which is great, which means now we can graph this section of the graph. Just like this. The other section of the graph, it cannot go here because it would fail the vertical line test if it went there. So that means it's going to go over here somewhere. We just got to figure out where. And hopefully when we find this x-intercept, the other x-intercept, it will show us, right? So to find x-intercepts, we set the top factors equal to 0. So the top factors are x and x minus 4. So the x-intercepts are 0, 0, and 4, 0. So at 4, we have another point, and so that means we're below that end behavior line, and then we're going to go through the x-intercept right there, and we're going to follow the end behavior up. And there's that graph. So maybe that one was a little bit easier than one where we had to plug in a lot of points, like letter E above, right? We had to plug in a lot of points in E to get that. But now you've seen almost every type of graph that I would ask you to try to graph. And again, there's a lot of different kinds. They're all going to look different in some sort of way based off of the horizontal asymptotes, the end behaviors, the vertical asymptotes. So really it just comes down to taking a lot of time to practice these questions and trying to start memorizing these steps, right? The expectation of the steps here in number 5. All right. If you have any questions, again, feel free to ask me. I'd be happy to answer any types of questions that you have. But yeah, hope you have a great day.